This is a walkthrough of the winner's curse simulation using Excel. To get started, we're just going to name this spreadsheet winner's curse simulation. And we're going to be modeling bidding on Outer Continental Shelf oil tracts, so it's sort of consistent with the original problem from the 1960s that Atlantic Richfield, ARCO, faced. So in cell A3, we're just going to enter mean, and then over in B3, you can enter either 10 or equals 10. And let's format that as a $sign. So what we're essentially doing is we're saying that the true underlying value of a tract that bidders are bidding on is $10 billion. Okay? And then below that in A3, standard deviation, you can either abbreviate this or spell it out. So I'm going to spell it out, standard deviation. And let's give us a little bit more room. And so this is capturing the uncertainty in estimates of the value. And we're going to say that that's 3 billion. So enter a 3 or equals 3 and format that as a $sign. And then what we want to do is we want to simulate having up to 10 bidders. So from one bidder to 10 bidders. So in A6, we want bidder number, and then A7, bidders bid, and then we need to keep track of the winning bid. And then we're going to simulate this 1,000 times. So we want to take a look at the mean winning bid from 1,000 simulations, not 10,000 simulations. And then we also want to look at how much the bidder should shade their bid down so that the expected value of the winning bid is actually equal to the underlying true value. Percent to shade bid. Okay, so we have that. We're going to take a look at 1 through 10 bidders. So in B6 through K6, we want the numbers 1 through 10. Bidder 1's bid. We're going to assume that the bids follow a normal distribution. The original analysis of this used what is known as a log normal distribution. You guys are familiar with the normal distribution, so we're going to be sticking with the normal distribution. And that normal distribution that they're drawing from is going to have a mean of 10 and a standard deviation of 3. So this is going to be equals norm, and I'm typing this in lowercase letters because I want to show you an error here. Norm.inv, and then probability, we don't give it a probability. We instead have Excel generate a random value between 0 and 1. Probabilities are between 0 and 1, so this will generate a random number. And then mean, and tell you to type mean, and then std.dev. Okay? And enter, and it'll come back with a name question mark, and that's because I skipped a step. Actually, 2 steps. So up here on B3, we want to name that cell mean. So click on the name box. Currently it's saying B3. We type in mean. That's now named mean. If we come down here, we still have this name question mark. If we click up here in the formula bar, we see we initially entered norm.inverse and rand as lowercase. These are now uppercase. It recognizes those as valid functions. Mean had been black, now it's in blue, corresponding to how this cell is highlighted or shaded. But standard deviation is still in black. That's because we did not name this cell. So just like with mean, we go up to the name box and we enter std.dev and enter. And now we get a value there. Down in B7, format that as a $sign and copy this across. And we want to keep track of the winning bid. Let's do that over here in, we'll start over here in F8. So this is going to be equals max. So the maximum bid with 5 bidders is the maximum from that range of cells, right, parentheses. But we want this so that if we copy this to the right or copy this to the left, that the F7 changes, but the B7 doesn't. And to do that, we put a $sign in front of the B. So now when we copy this over to the right and copy it to the left, we see that it changes there, okay? And you notice each time I enter something, these numbers change, and that's because of this rand function, okay? Okay, now what we want to do is we're going to do 1,000 simulations. So we come down here to B12, and we're going to enter bidders. And then in A13, we want auction number and bidders. In B13 through K13, we just want the numbers 1 through 10. Okay, and then in A14 going down, we want the numbers 1 through 1,000. So we enter 1, go up to the upper Excel menu, edit, fill, series, column. Step value is 1, stop value is 1,000. And that should have gone all the way down. It did. And then we want to use Excel's data table feature. Oh, actually before that, we need to tell Excel what to keep track of. We want Excel to keep track of the winning bid. So here, this is going to equal B8, and we copy this across so that we're out here and say H14, it's referencing H8, okay? It's not always going to be referencing that cell there. So, okay, and now we want to create the data table, so go over to A14, and on a Mac, this is a Shift Command right arrow, down arrow, that selects that range of cells, and then data, what if analysis, data table, column input cell, just give it A12, leave row input cell blank. And, oh, I know why it's not working. I had set up here, Excel preferences, calculation, automatic except for data tables. Let me uncheck that. Okay, so it calculates that. And if you don't like it calculating now, every time you press enter, you come up here to Excel preferences and do calculation and automatic except for data tables. So do that. Okay, so now recognize that if you go and change, if you change the mean, if you change the standard deviation, this information down here won't update, nor will the, when we calculate the mean winning bid from the 1,000 simulations, it won't change much. It will change because the values in row 14 will still change. So coming up here to B9, we want equals average, and we want these B14 down to B1013, right, parentheses. And you look at that, mean winning bid from, if you just have one bidder, the mean turned out to be 10. Yeah, it'll actually jump around a little bit. We just sort of got lucky on that one. Okay, and one thing to note here is that as we increase the number of bidders, the mean winning bid on average increases. See that? Just going across here, increases. Percent to shade your bid down, as the formula is equal to mean, so that's just that 10, divided by what the mean winning bid is, minus 1. And let's format that as a percentage with 1 decimal place. Do that and copy that across. And so with one bidder, yours likely isn't going to come out to be exactly 0%. It could be, usually it's in point something. I've had it as high as 2%, but typically it's about, 0.3 or so. And we see here with 10 bidders, we'd shade our bid down by 31%. So what that means is that if we say we had 5 bidders, this says we shade our bid down, should shade our bids down by 26%. So if all 5 bidders made their estimate and shaded their estimate down by 25.9%, or 26%, then the mean winning bid, if we repeated this over and over again, should be about 10. Okay, so we have that. Now, given that we specified the mean and the standard deviation up here, we can change these and see how that affects our results. So we're just going to leave the mean where it is. But suppose that there's greater uncertainty about what that true value is. To model greater uncertainty, we increase the standard deviation. So as a reference point, with 10 bidders, we were shading our bid down by about 31%. Suppose we increase this to 4. And now, since this didn't change over here, that's because I have the automatic calculation for data tables turned off. So if I hit F9, or on a Mac, it's function F9, and you often have to wait a couple seconds for it to catch up on the calculations. Now this is about 38%. So you would need to shade your bid down even more. And notice here this with one bidder, it's no longer 0. That had nothing to do necessarily with the standard deviation of 4 changing, though it would increase the uncertainty, and this is likely to stray further from 0 if it strays. And if there was greater certainty, so less uncertainty, with what the true underlying value is, suppose this was, say, a standard deviation of 1, and again, F9, function F9, and wait a couple seconds, and you see here we shade our bid down by about 13.3%. And again, your numbers will vary slightly from these. Okay, so you have that. The final thing I asked you to do is to create a line plot or line graph of either the mean winning bid from the 1,000 simulations or the percent to shade your bid down. So I've selected the former, insert, and line chart in this first 2D line chart. So it would look like that. If you instead selected percent to shade your bid down, it would look like that. Should be a nice, relatively smooth curve. If you have this jumping all over the place, you've done something wrong. Okay, so for example, if you did something like that, you selected the wrong row. If you did something like that, you selected the wrong row. You should have something like that or something like that, either way. So common mistakes that I see are 1, not naming these cells mean and standard deviation, so that you get this sort of that name question mark popping up here on row 7. The other thing I see is forgetting to put this $sign in front of the B, so that when you copy this over, it stays put there, but this goes over to whatever column you're in. And then let's see here, then I occasionally see students not, so for some reason when they do this mean divided by B9, they put a $sign on the B, and that's incorrect. Okay, you should see this, and that'll actually translate over into the graph that you do if you did that particular graph. So hopefully seeing this whole thing in terms of how it actually ends up being laid out is helpful for you completing the assignment. Thanks for watching.